Hello, everybody. Good afternoon to you all, and welcome to another session. Today is another great day, as usual, and today we have an interesting topic to cover. If I'm audible, let me hear something in the chat. Let me know if I'm audible. Good afternoon. Good afternoon, all of you. Good afternoon, and a warm welcome to today's session. Today, we want to move on to database services. And just like I mentioned, at Rita Africa, we are a community of like-minded individuals, and we are all going to the same destination. So moving forward, we are going to talk more about our community and how we are all going to play key roles to getting us to our destination. And we are going to celebrate everyone and going to help everyone to get to that destination. In a few months from now, you are going to be better data analysts, you are going to be better data scientists, you are going to be better cloud engineers, you are going to be awesome DevOps engineers, you are going to be great in software engineering, full stack web development, and in cybersecurity. And so we are working so hard, and we are all together in this vision. All right, so let's get into today's lesson. And we want to talk about the concept of databases in general. And we will also talk about AWS databases, starting with RDS, Relational Database Service. So I'm going to play a short clip. After this particular clip, we will get into the lesson. Now, this clip is important because databases use a type of storage like EBS for block storage. And so this video is going to be about EBS. Let's listen to it carefully and we'll connect it to the lesson. So if you are ready, let me see ready in the chat. Ready in the chat. Good to see you all. Louise, Dachomo, Letitia, Wildom, Louisa. We have Louisa. All right. So this is why, Louise, we've always been asking, are you in the morning or the evening? So now we've seen that we have Louise and Louisa. All right. Welcome all of you. Nyapandi, Yvonne, Sylvia, Timothy, Jael, Ashnafi, Emanuela, Maxwell. Welcome, welcome, welcome. A warm welcome to you all. So let's get ready and watch this clip.
Amazon Elastic Block Store, also known as EBS, provides persistent block storage for use with Amazon EC2 instances that can scale and adapt to meet your performance requirements. Tightly integrated with EC2 instances, Amazon EBS provides high-performance, low-latency block storage with 4 different volume types to meet the needs of any workload. SSD-backed volume types deliver low latency and the highest IOPS, while HDD-backed volume types deliver the highest throughput, with 2 options for each type, depending on your performance and budget needs. SSD-backed volumes are best for boot volumes or transactional workloads, like enterprise applications, relational databases, and NoSQL databases. HDD-backed volumes are best for applications producing streaming I/O, including big data applications, data warehousing applications, and log processing applications, or for staging application-level backups before snapshotting to Amazon S3. For any type, you'll have consistent performance and be able to connect different volume types to a single EC2 instance for applications whose components have different performance profiles. Because you can modify live volumes without affecting performance or availability, you can adapt easily when your needs change. And point-in-time snapshots enable efficient backup, recovery, archiving, and creating new EC2 instances, all stored in Amazon S3, which has 11 nines of durability. With encryption in flight and at rest, Amazon EBS adheres to the most stringent compliance standards and regulations. Plus, Amazon CloudWatch can provide alerts when you need to adjust capacity or volumes. Consider it for your next high-performance application deployment in the AWS cloud. Find out more at aws.amazon.com/EBS.
All right, so EBS, Elastic Block Store, is a powerful storage service from AWS, and it is best known for block storage, and examples of that is database storage. And so this really helps us to connect this to the databases we are about to look at, because this is one of the storage services for our databases. And we have also learned how EBS is also storage for EC2. This means that our databases, as they are also being stored on EBS, they also have a relation with EC2. So our databases are also going to be run by EC2 instances as well. And this helps us to really connect the dots and get a better understanding. However, most of the services we are going to be talking about, like RDS, they are managed services. Some of them are completely serverless services. And so we are not going to interact with any block storage. We are not going to interact with any EC2 instances. Since they are managed, it means that AWS takes care of the setup and the management and everything. All right. So welcome once again to another wonderful session. I want to continue and take us deeper into this lesson. We are still learning about AWS, and since we started this course, it has been so wonderful. I have loved this course myself so much, and this has introduced us a lot to modern technology, a lot to how technology truly works, a lot to cutting-edge technology, and has inspired us to see how some people have dedicated themselves to operate at the cutting edge and to invent the cutting edge. And so if you look at AWS and what they are doing, it's so amazing. Last week, they had their 2024 reInvent, and that is where they introduce the new things they are doing and the new services they are launching. They launch a number of services, new services, a lot of them actually. And so every year at reInvent, they keep launching services, and you can see how they are thinking, how they are working. And one thing I like about AWS is how customer focused they are. In the reInvent 2024, just last week, they were celebrating how they have made customers save 4 billion US dollars by their optimizations and the improvement of their services. I was just thinking to myself, so this actually means that you have lost $4 billion. But that was not the focus. To them, they have let customers save $4 billion through simple optimizations that they did, like some of the intelligent tiering that we learned about in S3. And with this intelligent tiering, the system automatically moves your storage to low-cost storage based on the number of times it has been accessed in a month or in 3 months or in 90 days or a number of days. Once the system sees that this particular storage is not frequently accessed, they move it to the infrequently accessed tier automatically, and just by their own implementations and all that they are doing, it is making customers save more and do well. And AWS is truly inspiring with all the amazing services they have. They have compute services. We've seen these services, EC2, Lambda, Elastic Beanstalk. We have ECS, EKS, Fargate. We've learned a lot about compute services. And when it comes to storage services, we've learned about S3, EBS, Glacier, EFS, and we've learned a whole lot. Now we are moving on to database services. And before we wrap up all the little parts, we are going to connect all of them, and we are going to be fully enlightened about this, and we are going to really do well in the examination. And I truly hope that you are learning. I hope that you are paying attention. I hope you are focusing on the course. I hope you are following the course, because this course is going to make a difference in your career. This course is amazing, amazing. If you're a tech lover, you should love this. And I love this so much. And it is something that is going to help you to think better, learn better, and be able to improve very, very well. After this course, when you get into specialization, you'll be able to operate much better. And I'm so happy. So today we are going to talk about database services, and these are some of the database services like RDS, DynamoDB, Aurora, Redshift, Amazon Document DB. And to talk about database services and what we are going to get into, I'm going to give you an overview of databases so that those of you who do not have a strong foundation in databases, I think if you're in tech, you need to really take a time and get into databases, work with some databases, build a web application, set up MySQL, and yes, work with databases. And WordPress allows you to interact with MySQL, but at a very, very basic level. You just create the database, which is very, very easy. The seniors, all of you have done that. It's very easy to create a database and also work with PHP if you are working with WordPress. But that is very, very basic because everything is already there. You are just um, kind of importing, and you don't really run any queries. You don't really type any SQL statements. The only thing that you do maybe is to get into the backend and um, use MD5 to change your password in the backend in the database, or probably after migrating, you go to the options and you change your URL to your domain name. Those are very, very basic things. I'll be happy if you can just create a simple web application, create a MySQL database, and you can just create a form and the entries will go into the database. The entries will go into the database. After that, you can go to the database and run some queries. SQL. These are fundamental skills, very, very fundamental skills in tech, very, very basic, very, very fundamental skills. And we need to have those experiences. We need to learn those kind of things. So I'm going to start with a basic general overview of databases, tell you a little bit about databases before we zoom into RDS today, because today's lesson is about RDS. Please put RDS in the chat for me if you can hear me. I don't know if I'm audible and I'm visible. RDS, thank you, Sylvia. Thank you, Norbert. Thank you, Yvonne. Thank you, Timothy, Frida, Louisa, Wildam. Thank you so much. All right. All right. So RDS. So now RDS, listen to this. RDS it stands for Relational Database Service. Very, very simple. Relational Database Service. Please put that in the chat for me. Relational Database Service. Please put that in the chat for me. Relational Database Service. Thank you, Jael, Valentine, Paul, Ashanafi. You guys are working so hard, and I'm so proud of you all. Relational Database Service. All right. So that's what RDS stands for. And it is a fully managed relational database service provided by AWS. Simple. Now, when we say fully managed, just like we explained in our previous session, fully managed refers to the fact that AWS handles the management. So you don't have to work on the infrastructure for databases. You don't have to install any software for databases. You don't have to maintain it. You don't have to upgrade it. You don't have to secure it. You don't have to do anything. You just use it. Okay. And in using it, you just set it up and then you go ahead and you use it. So when we say fully managed, and when I say set it up, I'm just talking about you providing the name you want to use and the features you want to select. That's all. And then AWS takes care of the rest for you. It is a relational database service. So you type relational database service, and I want you to type relational again. Please type relational again because this is a main point. We know databases, we know that there are database services, but this time we are talking about relational. So that is where we need to build our understanding in, and it is important for us to understand this. So I'm going to do a general introduction to databases and just talk a little bit, very, very short, about databases, and we'll take it from there. So what is a database? What is a database? Again, I have mentioned that without databases, we don't have technology, okay? And so if you have a future in tech, a database is something that you should have an experience in or with. You have an experience in databases. Maybe not much like a data analyst or a data scientist, but at least you should work with a database at some point in the to the level where you can create a database comfortably. You can input data in the database and you can query. The querying part is the main part. Please type query in the chat. If you know how to spell it, just type query, however you heard it. Type query in the chat. Let me see who can type query. Norbert typed it. Valentine got it. All of you, Yvonne, Maxwell, query. All right. So you need to query a database. And to query a database, we use a language called structured query language. Structured query language. Structured query language, or SQL, or what we say SQL. That is the language we use. So as part of the tech stack that you build to be able to operate anywhere, listen to me, whether in cybersecurity, cloud, everywhere, you need this. You need Python, you need SQL. These are very, very vital and very, very important languages to learn. SQL. Thank you, Ashinafi. SQL. Please type SQL in the chat if you have not typed it already. Type SQL in the chat. And if you're a data analyst, you need to be heavy on SQL. You need to learn SQL so much, so much, so much, because that is the language we use for querying structured databases. So let's start. A database, don't be chewing definitions, okay? Just try and understand them. So a database is an organized collection of data held in a system. So a database is an organized collection of data held in a system for easy access, management, and efficient retrieval. This is a clear and a very simple definition for you to get a clue of what databases are. And it talks about how the data is organized. And so when we say a database is like a set of data that has been bundled together into a database. Is like a set of data that has been bundled together and it is stored in a system. Okay, I'm thinking of a terminology to use that will let you get it, but just think of data that has been, first of all, very well organized and has been put together into like a power source. I don't know what to say, but data that has been put together, bundled together, and held in a system in a special way that you can access it You can manage it. You can modify, increase, do whatever you want to it. And the most important part is that you can retrieve it. Okay. So it's like a source of information, but it has been designed to be very organized. All right. It has been designed to be very organized, and it is stored in a computing system for easy access. So the way it is designed so that access is possible, management is possible in terms of updating, deleting, adding, whatever. And then the most important part is retrieving. So in all, we are just talking about data. That's data that we have organized, collected, and stored somewhere. Now, let's just move straight to the types of databases. Databases can be broadly categorized into two types based on how they structure and handle data. Listen to that. Based on how they structure and handle data. How many types did I say? If you heard me right, please put it in the chat. How many types? They can be broadly categorized in two. So we have relational database. This is where the lesson is coming from. Relational database, and we have non-relational database. So when I ask you to type relational database, this is it. So now, once we know that we have this information source or data source where we can pull out data anytime, we can also go and store data anytime. That has been carefully designed and organized. Right now, we are saying that we have two categories of databases. One type is called relational, and that type is called non-relational. Now, if you look at this diagram is telling you how data is structured or held. The relational database is more structured and organized than the non-relational database. And so it is perfect to say that relational databases are table-based databases. This type table-based. I like that. I like that type table-based. Relational databases are table-based databases. This means that the data has been really, really organized into tables in rows and columns with special features so that retrieval is possible. We can retrieve anything from that table. We can point to any part of the database. We can access any part of the database because of how it is designed. And so once we say relational databases, we are usually talking about table-based databases. All right. Saying table-based doesn't really explain the fact that it is relational, but then it is relational because number one, it works with tables. And if you want to get a clear picture of a database is made up of tables. All right. A database is made up of tables. Now listen to this. In a database or in a relational database, we have multiple tables. The way we said the data has been organized, how we did it, or how it is organized is by using tables, rows and columns. And we use multiple tables for different entities or different parts of the same data or the same database. Let me give you an example. If you are creating a university database, okay, you want to use a relational database model for that, okay? Now, the fact that we have a university database doesn't mean that the database is the data. Okay, listen carefully. The database is not the data. The database holds the data. Where can we find the data? We can find the data in tables. How many tables? Several tables. Captures every aspect of the university and the operations of the university. For example, we have a table for courses. We call that an entity. And so all the courses will be structured in a table in rows and columns. Is that all the university is about? Is the university only about courses? Is the university only about courses? Okay, someone said no. I was waiting for like 5 minutes before someone said no. The university is not only about courses. So what else is the university about? What else is the university about? What else is the university about? Who can tell me? Students, okay? Wonderful. Students, I like that. And so we have a table on courses. We have a table on students. What else is the university about? Someone says admissions. Yes, admissions. We have a table on admissions. Okay, what else? Lecturers. We have a table on lecturers. Think about that. We have engineers who create databases, all right? And you are one if you are a software engineer, or if you're a data analyst or a data engineer. When we are creating the database, listen, for example, when I'm working on a project for university, I am responsible to think about all the entities in the university, okay? Because people create the databases. So if I'm creating a database for university, I will sit down and think about all the possible entities in the university. I know that we have courses, we have students, we have lecturers, we have admissions, we have classes. I know that we have fees, we have payments, we have results, we have different things. I have to think about all of them. And each one is a table. After I think about all the entities, then the next step is for me to design the tables for each one. And this is what I'm talking about, that it's an experience you need to have to create a table, to design a table. Now, designing a table or designing a database, it goes beyond the known entities of the university, okay? It goes beyond the known entities because technically there are certain tables that I have to create myself to be able to make the system faster and better. Okay. The first point I'm trying to pass across is that when you think about a database, especially a relational database, it is made up of tables. Not one table, multiple tables until we have captured the purpose of the database. If it is an e-commerce website and I am creating a database, I'll think of products as one entity. I'll think of customers. I'll think of orders. I'll think of deliveries. Think of all that I need to think about until I have captured everything about the e-commerce platform. Okay. So the point here again is that a database is made up of multiple tables. So when you enter a database, a relational database, what do you see? When you enter into a database, you should be expecting tables, all right? That is the first point. The second point is this. These tables are connected to each other to establish relationships, okay? They are connected to each other to establish relationships. For example, we have admissions or registrations, like someone said. Now, if you talk about admissions, first of all, who gets admissions? Is it not students? Okay, fine. It's students, right? Good. But you know that we have a students table already. All right. Now, what are students admitted to? They're admitted to courses, right? And we have a courses table already. But we need another table for admissions. Now think about it. The admissions table needs a relationship with the students table and needs a relationship with the courses table. Also, the students table also needs a relationship with the courses table. Why do we establish these relationships? To reduce data redundancy. Let's type data redundancy in the chat. To reduce data redundancy. Type data redundancy in the chat. When we say that, this is what it means. Redundant data refers to excess or unnecessary data. Let me explain it this way. In the past, when data was stored in normal text files, we had a lot of redundant data, okay? There was no way of letting the different files communicate. And so, let's say you are creating a file for your customers to give you a list of your customers and then a list of orders. All right. Now, in the orders list, we need to know the customer who bought something. We need to know the telephone number of the customer who bought something. We probably need to know the address. We need to know the product. We need to know how much, the quantity and the price and everything in the orders table. But we have a different file for products. We have a different file for tables, sorry, for customers. And anytime we are creating an orders file, we have to repeat the customer information in the orders file. Meanwhile, the customer information is already in the customers table, and the orders or the products information is already in the products table. So repeating that data in the orders table is unnecessary, taking up unnecessary space. We call that redundant data. Now, you have to do that because there's no intelligent way of the orders table communicating or orders file communicating with the customers file and the product file. That is what relational databases solve. Relational databases are databases that create relationships. Now, they create these relationships because you don't have to repeat data anywhere. If you create a table for the orders, you don't have to type a customer's name again. You just build a relationship between the two tables. What if one customer changes their address or their telephone number? In the old system, you have to go to this file, edit it, go to that file, edit, go to that file, edit all the time. What if there are a lot of places that the customer's details are stored? In relational databases, we don't do that. We have customers' details only in the customers table. Anywhere it is needed, it will be sent or it will be connected to based on the relationships established. So you don't have to own yours, just have a relationship with me, and whatever you need, you have it. So whenever you are creating a query or you are showing or writing a query to display a list of orders, that query will definitely show the customer's name, their address, and all that. But the data didn't come only from the orders table. It came from the orders table with its relationship to the customers table and the products table. And so these tables are designed in a way that relationships are possible. This is why we call them relational databases. And what they use for the relationships are called primary keys. Please type primary keys in the chat for me. Primary keys. Primary keys. Primary keys. Let me see the first person to type primary keys. Thank you, Frida. Thank you, Maxwell. Now, if you type primary keys and you have typed primary keys, please type foreign keys as well. Foreign keys. Okay. So we use a concept of primary keys and foreign keys to establish the relationships. Okay. I'm not going to go into details right now because it's a lot of things to do, but I'm telling you how the relationships are created. And so we have relational databases. And in this environment, this is where SQL is king. So we have structured query language as a language to query these databases. It loves that environment, and it was designed for that environment because these types of databases are structured. And so we can use that language to do anything. It's an incredible language. All right. The other type of database is what we refer to as non-relational databases. Non-relational databases are also referred to as NoSQL databases. Please type NoSQL databases. NoSQL databases. So relational databases, we have mentioned how they are they establish relationships, and we use the SQL language to operate them or manage them. For the non-relational databases, they are NoSQL databases. And for these NoSQL databases, they are not table-based. They can be key value pair based, like the way we have JSON or Python dictionaries. If you remember Python dictionaries, then you know a little bit about JSON. So JSON is a key value pair structure, and it is a non-relational database. We also have Graph or GraphQL, which is also non-relational. We'll get into all of these very soon. And then we also have documents-based data. All right. So these are non-relational. Relational databases are or have been our strongest method of managing data and handling data. And it's an amazing solution. But as technology is improving, we have created advanced systems today that support NoSQL databases. And so today, we have modern technology. Modern technology is adopting a lot of NoSQL today. Modern technology is adopting a lot of NoSQL today. So although RSQL has been powerful and popular, NoSQL is also advancing rapidly now. And so in software engineering, these are areas to also pay attention to. Over here, I've given you a small picture of relational database and non-relational by using JSON and tables. So in the table, this is how the database is designed. You can see one entity or one table. You can call table an entity. This entity is called student. And this is just one of the tables in the database. This is how it is designed. We need an ID. We need name, surname, age, and whatever data we need. Okay. These are the columns and these are the rows. I want you to picture this way of storing data right now. Just picture this a little bit and tell me about what happens with a column and what happens with a row. Tell me something you are picking out by looking at a column. When you look at a column, what do you see? And when you look at a row, what do you see? Anybody? All right. So when you look at a column, let me see the first person to say something. Someone says that each has different data type. Okay, that's powerful. Wow, that's great. It's great to see that. You see, if you look at the age column, you are seeing a data type, right? You are seeing integer, right? So when we are designing databases, we actually design the columns and we indicate the data type. The concept of data type is also in databases. Whenever you are creating a database, you have to create a data type. So age, you have to say integer or int, tiny int, whatever you want to choose. Surname, what type of data type do you think it is? The surname, what type of data type do you think it is? All right, it's a string. All right. But in platforms like MySQL, instead of saying a string, we can say varchar, variable character. When you are designing a database, you see all of this. In Access, you just say string. All right. If you look at the NoSQL, you are seeing how it is. This is key value pair, and it's non-relational. Let's continue. Look at relational databases. Relational databases store data in structured tables organized into rows and columns. Now, this is what I wanted to say. Let me say it before I move to relational databases. When you look at a column, you actually see one type of information, okay? Although you see the data type, you also get one type of information. What do I mean by that? For example, the column that says surname, it captures all the surnames in the table. So we are getting that type of information, all the surnames. The column about age captures all the ages. So because I am getting all the ages, I can do something about that column, write a query to go through all the ages and pick out some of them for me. When you look at a row, what do you see? When you look at a row, you see information about a single person. For example, everything on row 1 is about John. Is it true or false? Everything on row 1 is about John. Is it true or false? All right. So the 19 you are seeing on row 1 is talking about John. The surname you are seeing is talking about John. So everything you see on row 1 is about that person. So a row captures all the details of a single item. We call that a record in a database language. Record. Please type record in the chat for me. Record. Record. There are other names that we can use. I'm just giving you little for now so that you can digest. So in a real database environment, we don't use the term row. You only use the term row when you are maybe introducing database concepts or you are speaking in simple language. But we use a technical term records or the terminology record. For columns, we use the term fields. Fields. Please type fields in the chat for me. Fields. There are others, but I'm just giving you one for now. So when you hear fields and records, it simply refers to as columns and rows. All right, that's what I wanted to say. Now, talking about relational databases store data in tables, organized in rows and columns, with predefined relationships. These type relationships in the chat. Are you in a relationship? Don't answer that one. But these tables, they are in relationships. Relationships where and how. You can see that we have relationships between the tables. So the tables have relationships, okay? They use structured query language or SQL or SQL for defining, querying, and managing data. Examples include MySQL, PostgreSQL, and Microsoft SQL Server. Please type Microsoft SQL Server in the chat for me. Microsoft SQL Server. Please type that in the chat for me. Microsoft SQL Server. Please type that in the chat for me. Microsoft SQL Server. What are we talking about? We are saying that all of these are relational databases. Okay. Then please type MySQL in the chat for me. If you have typed Microsoft SQL Server, please type MySQL in the chat for me. All right. So MySQL and Microsoft SQL Server, they are not the same thing. They are different relational database systems. They are not the same thing. They are different database systems. All right. MySQL is very popular in web applications. Those of us who have been building websites and web applications, we know MySQL so well. Then Microsoft SQL Server is usually used in Windows environment. It is also another database system. Right. So what have we said about relational databases? The only thing we have said is that they use tables. Please put that in your mind, okay? They use tables, number one, and they have relationships. So type tables plus relationships. That's what we are talking about. So everything we've said about relational databases, that's what we are trying to say. Tables plus relationships. Tables plus relationships. So they use tables, they have relationships. If you go into details, you will know that there are multiple tables. The tables are in rows and columns and all that. And they use relationship using primary keys and foreign keys and all that. Now, when it comes to non-relational databases or NoSQL databases, non-relational databases, often referred to as NoSQL databases, handle unstructured or semi-structured data. They are like flexible and scalable. They are highly flexible and scalable using formats like key value pairs, documents, or graphs. Examples include MongoDB. Please type MongoDB in the chat for me. MongoDB. All right. So today, one of the most popular tech stack that is advancing in the field of software engineering and web development is the MERN stack. And we know that the main stack uses MongoDB, and NoSQL is becoming more and more popular today. All right. Let's talk more about relational databases. Let's talk more about relational databases. Now, relational databases organize data into tables. I've already said that. Where each table consists of data about specific entities or subjects. I've already said that. This means that in a university, one table is for one subject, another table for another subject or another entity. You need to cover all the entities possible within that environment to have your database. These tables are designed to recognize relationships between each other using primary and foreign keys, which link records across tables. I've already mentioned this. So over here, look at a picture of a relational database. This is an e-commerce environment. Okay, watch this. Now, we have a table for customers. And see how we designed the table. This is wonderful. You see, if you are building an e-commerce platform, I do this every day, okay? I didn't say yesterday I did one, but I do this all the time. If you are building a platform, you, the developer, you are responsible for creating the entities or the table. How do you create it? You need to think about the system and any entity that should exist or that is needed to make the system function well. So this is a very simple one. I'm sure in a real world scenario, we'll have more entities in this database. So this is what we are saying. What you are seeing is a database. What are you seeing? You are seeing tables and links, right? Tables and links. This is what makes it a relational database, because this is how relational databases look like. In a relational database, you have tables. Each table is about one subject or one entity. So we need a table for customers. We need a table for products. Then we need a table for orders. Then we also need a table for categories. See? See why I said sometimes you need to create new tables. And then look at these other details. After doing this, we establish the relationships. We establish the relationships. Now, after thinking about all the tables you will need, after writing them down, then you pick each one and you design it. Let's pick the customers table. If I'm creating my customers table, what information will I need about my customers? You tell me, what do you think we'll need about customers? What information do you think we will need? Anybody in the chat? Okay. So I like the way Nyampandi is straightforward. Okay. Name, address, age, and more. Okay. Think about everything you need, because if you don't capture it, what it means is that you will not have it in your system. All right. Listen to that. If you miss any information, it means you are not going to have it in your system. So your system should be comprehensive enough to have every relevant data. And for the purpose of querying, it is not ideal to just have a field called name. We would rather want to have first name and last name, because a time will come we may want to list all the first names that start with or that are equal to Emmanuel. So we want to know all the Emmanuels we have. And we will use the first name field for that query. You see, the first name, the fields, they help you to run your queries. So you need to design it in a way that So for example, name, you have to separate it because something will happen and you may want to target a particular surname. And to target a particular surname, you will need the surname to be separated. You run your query only with the surname. So that is it. And one thing you can see about all the tables is that they all begin with ID. They all begin with ID. Why do we have to create an ID? Do we always write IDs? In the real world, we may not always write IDs. Someone will say, okay, for numbering. Okay, but in databases, the purpose is not just for numbering. The purpose is for the primary keys. So you can see PK, PK, PK on all the tables. Can you see PK in all the tables where the IDs are? Can you see PK, 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 PK? Yes, I like that. Frida says to uniquely identify them. All right. So the primary key, one of the purpose of the primary key is to give every record a unique identifier. I love databases. It's so wonderful to learn about databases. You see that when the records begin, because of the primary key, and most of them, you can see that they are all integers, right? So you can see the data types now. Some are varchar. So the varchar, you are seeing it and the amount of characters. Okay. So the primary key here, number one, its purpose is to give every record easy identification or a unique identifier. This is how we design our tables in a way that we can point to any specific detail we want. Because every record, because of the PKs, have unique IDs. So I can use an ID to pull out a single person. And I can use a field to pull out a single cell. It's amazing. We don't use cells here. Well, we use cells, tables, rows, and where they meet, we call it a cell. So the way they are designed, you can pick anything, all right? Okay. Now, let's look at the lines first. You can see how they have the lines. The lines are the relationships, and they are set up using the primary key and the foreign keys. Have you seen FK somewhere? Have you seen FK somewhere? Okay, someone has seen FK. FK stands for foreign key. It's so interesting. All right. This one, if we say we are talking about all of them, we're not close to them. But this is so interesting. I like this so much. All right. Because of the relationships, look at how they have designed the other details. If you look at the other details, you can see that it has a product ID, an order ID, and then it has a quantity. Now, the order ID is being pulled as a foreign key from the orders table. Now, the orders table has a customer ID in it. Okay. It has a customer ID in it. Now, because of the customer ID in the orders table, once we pull an order ID, we have the order and the customer. And we don't need the customer's information. You see, imagine in the orders detail, we are now going to write customer name, customer telephone, customer. It is not done. Because of the relationships, we only need the ID. When you write a query, the query can go around and pick all the details. At the end of the day, when we list the order details, you see the customer and the product and the price and the email and the telephone and everything. This is the power of relationships in tables and the power of relational databases. Let's talk about a DBA. Please type DBA in the chat for me. DBA. DBA stands for Database Administrator. All right. There are some people who work as database administrators alone, but every software engineer is a database administrator. Every data analyst is a database administrator. Every data engineer is a database administrator. Every data scientist is a database administrator in one way or the other. We have people employed as database administrators specifically. Now watch this. This man here is a database administrator. And the work he's doing now is the work I do every day. When I'm building a system, this is what I do. What is he doing? He's designing a database. How? He knows all his entities, all the tables he wants to create, and he's creating the tables now. And he's also linking them. Look at where the arrows are pointing. Most of the arrows are pointing from ID to ID to ID to IDs. Those are the primary keys and foreign keys connecting tables to tables. At the end of the day, the entire table is so intelligent that each table knows every other table and can fetch data from everywhere, and we can retrieve any useful information. Databases are designed for efficient retrieval. We can retrieve any information from the database because of how it is designed. If you are designing a table, what do you think about? You think about the fields. So what is the man writing? He's writing the fields. He writes the table name and the fields he needs. What are the fields? I told you. What are the fields? What are the fields? What are the fields? Who remembers? The first person said the fields are the columns. Thank you, Khaled. Okay. The fields are the columns. You see? When you are designing a database, that's what you think about. That's what we use to set it up. That's what we use to create it. When we are done, when the data is coming in, the data will now form the rows. But the design and the structure is made up of the fields. And a database administrator, or a DBA, is responsible for managing and maintaining the relational database, including tasks such as configuring, monitoring, optimizing databases, and designing the databases. I do this every day, and I love this. I like databases. This is so wonderful. All right. We are going to watch a short clip about a database administrator talking about databases. So just pick some information from her to add to what we've talked about so far. And my advice is that you get an experience with databases. Okay, just have an experience, like what he's doing. Take a sheet of paper and design a database one time, and then go to MySQL and implement it. Build a simple application to interact with the database. There are some things I only feel, and I only feel like we have more and more time to go through all of that. This is at the heart of everything you do. If you're in security, this is where security begins. If you're in development, this is where it begins. If you're in data, this is where it begins. All right. So let's listen to this database administrator from IBM, and let's listen to what she will say. We'll pick one or two from it, and after that, we will continue. We'll take a short break after that, but let's finish the video first. I have a comment or two after the video. We'll take a short break, and then we'll continue with the lesson. If you are ready, please put ready in the chat for me. I'm going to share my screen. and I will play the video.
Hi everyone, today I'm going to be talking about databases. So let's start by understanding what a database is. A database is essentially just an organized collection of information. So with databases, they really start at data, right? We have data as a core unit that goes into all these databases. And let's think of how much data we all generate every single day. Whether we check our social media right when we wake up, we do some online shopping, we log into our work computer and send a Slack message. This is all data that's being generated. And we want to make sure that we're storing this data in a way that is efficient and that we're able to make use for it. So this data often goes into tables, and these tables are in a database. And then these databases are used to extract business intelligence. We take this, we derive business intelligence from it, and ultimately what we're doing is really making decisions that go back and benefit the customer. So there are a few different reasons why someone would want to use a database. There are a lot of companies today that are still storing data in flat files. So if you think about an Excel sheet, right, that's going around an organization, that's not very efficient. So storing all your data in one area really helps with efficiency. It makes sure that people who need data are able to easily get access to that data. It also helps with making sure that you have the most updated version of your data available. So you're not working off of old information that is in some sheet that you were given access to. And we can say this also helps with consistency. And it helps with security. So again, think of a flat file that is going around your organization that different people are working off of and sending around. It's hard to keep track of that, right? So we want to make sure that all of our data is very secure. So security is key, and it's why people leverage databases rather than just using a flat file or an Excel file and sending that around. There are a few different database architectures that people leverage to really make use of their data. Firstly, we have one-tier architecture. So this is when you have a database and an application on a single server. So think of Microsoft Access. You log on to an instance of this that is running on your home computer. You ask the database a question. That is one-tier architecture. It's all running on a single server. Then we have two-tier architecture, where we have our database and some applications that run off of it. And taking this just a step further, we have three-tier architecture, where we have our database, and then a layer in between our database and our architecture called a server, and then an application, or multiple applications. So three-tier architecture is actually the most common architecture that we see today. And this is because there are a lot of added benefits that clients have when they leverage three-tier architecture as compared to other architectures. Firstly, they have the added benefit of security. You have this layer in the middle. This has business logic and business rules that need to be followed. So it really helps ensure that all the questions that are being asked of the database are vetted thoroughly first. And it also serves as sort of a firewall, right? You have this extra layer that you have to go through to get to the database. So it does really help with security in that sense. There's also increased scalability. We can scale each of these tiers out independently from each other. So we can scale out our database if we need it, our server, and our application. An additional benefit that we have with this is reliability. Think of in our one-tier architecture, if our database goes down, then it's all on one server, so it's difficult to really get any insight from this. Now, since it's all separated into three separate tiers, then one outage doesn't really impact what's going on in other tiers. So we have increased reliability in that sense, and scalability, and faster development. So you can actually develop each of these tiers separate from the other tiers, and that really speeds up the time to develop your overall database architecture. And the database world is also rapidly evolving. We see 3 different tiers here, 3 different architectures, but the database world has been rapidly evolving since databases were created. In the 1960s, actually, we had our first ever database, and this was created by IBM. It was called IMS, and it was a hierarchical database. Then we had relational databases, which IBM also really helped pioneer. They had System R, which was one of the first relational databases. SQL to help interact with the relational database, ask questions of the data, and get information back. And if you can guess who created that, that was also IBM. And now we're in a new era where we see a lot of NoSQL databases and cloud databases. So cloud databases are a little bit different than the traditional database. This is a database as a service. So when you have a database, there's a lot that goes into just managing it and keeping it up and running. You have to make sure that it is fully secure. You have to make sure that you are maintaining it, that you're doing updates on it as needed. And a lot of that back-end work takes up a lot of time. So databases as a service takes care of all of that. You have some third party that is managing your database. And with this, your DBAs can start focusing on more high-value work. And it really brings this added benefit to customers. Now they're not focusing on just keeping up the database, they're focusing on really getting intelligence from their data. So we can see that IBM has long since been a pioneer in the database world, and that hasn't changed at all since the first database was created. We have been across all the different areas in the database world. We've had products that have really catered towards different goals and different needs, and we continue to do that. So thank you for your time, and I hope you learned a little bit more about databases today.
All right. Did you learn a little bit more about databases today? Tell me one thing you learned about databases. All right. Can you hear me? Okay. All right. Thank you all. All right. So let's just take a stretch break, and then we will add some more to what we've learned about databases. Then we'll take it from there. So we'll take a short break, and then we'll continue. We'll meet again in 10 minutes, okay? All the best. Take care. All right. So welcome back from the short break. We want to continue our studies on database systems and RDS. We've been talking about what databases are, types of databases. We've discovered that we have relational databases, we have non-relational databases, and I want someone to mention one type of relational database and then one example of non-relational database. When I say type, I'm talking about a system or example. So just give you one example of a relational database and an example of a non-relational or NoSQL database. So Valentine says MySQL, that's perfect, very popular. MySQL, that is for relational. For non-relational, who can mention one? NoSQL databases, who can mention one? All right. So Louisa says MongoDB. Thank you. Thank you. All right. Right now, we want to talk about database management systems. Database management systems. Database management systems. So if you can hear me, please put DBMS in the chat for me. Put DBMS in the chat for me. DBMS. All right. So DBMS is database management system. And if you are studying about databases, most of the time you are going to be dealing with a lot of acronyms. Database itself, we use DB to stand for it. So most of the time you hear DB, and DB stands for database. When it comes to database administrators, you are going to hear DBA. So in the field of databases, we use a lot of terminologies. We're going to be hearing SQL. What does SQL stand for? SQL stands for, and you are going to be hearing a lot of acronyms. So let's continue with what DBMS is. DBMS stands for Database Management Systems. And it says that a DBMS is a software tool that provides the necessary functionality to create, manage, and manipulate databases. It allows users to efficiently store, retrieve, update, and organize data, ensuring data integrity, security, and accessibility across different platforms and applications. So just like we watched in the video, we saw all the benefits of using a correct database system. So when we say database system, what are we talking about? We are talking about a tool that gives you the functionality to manage or manipulate the database. We are talking about a tool that gives you the ability to manage the database. So we have a database and we have a database system or a database management system. So this is a management system. All right, that's what the DBMS stands for, management system. This system is used to manage a database. So think about it. We have the database, which is the collection of structured data or collection of data. Then we have a tool that is used to perform operations on the database, or the tool that allows you to handle the database, manage it, and manipulate it. All right. Now, this particular tool that we are referring to as DBMS, we have some for relational databases. We've already been talking about relational databases. So the tools for relational databases, they are referred to as Relational Database Management System. Who can tell me the acronym? Relational Database Management System. So when you see DBMS, you need to find out whether it's a relational DBMS. And a relational DBMS, now we understand what it is because we know what relational databases are. And we know that there are some tools called database management systems. So relational database management system, or RDBMS, so in the field of databases, we talk a lot about acronyms, okay? RDBMS is a type of DBMS that stores data in structured tables and organizes data in rows and columns and operates on relational databases. So if I were to give you my own definition, A relational database management system is a DBMS that performs operations on relational databases. That is a definition I will give you myself. It performs operations on relational databases. So we know that we have non-relational databases and we have relational databases. So this is a relational database management system. I'm giving you some examples of the relational database management systems out there. So far, we are not yet in AWS. I'm just contemplating whether we should add the content of AWS right now. But we are still talking about databases in general, okay? So in the world of RDBMS, these are the RDBMS over there we have in the world. So when you hear MySQL, which you can see here at the bottom right, MySQL is a relational database management system. Is MySQL a database? MySQL is a relational database management system, or MySQL is a database management system. How about Oracle? What is Oracle? Oracle is a relational database management system. One of the most powerful and the most secure database management systems. One day I was teaching microcomputing and we got to databases and I was teaching at a certain to some absolute beginners in a rural community. And I asked them, what is Oracle? I'm teaching IT. I asked them, what is Oracle? Someone said, I know. The person said, it says Nigerian movie. Nigerian movie is Oracle. To them, they've never heard anything about Oracle. But Oracle is not a Nigerian movie. Oracle is a company and it is a relational database management system. Oracle has been instrumental in the field of databases. Without Oracle, we probably will not have databases as we have it today, especially relational databases. The video we watched about IBM has also been instrumental in relational databases, but Oracle has also been really, really instrumental in databases and database management systems. So what we are looking at are the examples of database management systems. We have PostgreSQL, we have SQLite, we have Microsoft SQL Server, then Microsoft SQL Azure. You can see that Azure also has SQL and other types of database platforms here. We will have Microsoft Access. Microsoft Access is also a relational database management system. So all of these are database platforms. Okay. So please pick one of the relational database management systems and type it in the chat for me. Just pick one, any one that you want to, and put it in the chat for me. I don't know if my chat is working. Let me see. All right, so Frida says Oracle, we have PostgreSQL, Norbert, MySQL. All right. Okay. Now let's talk about database engine. A database engine is a core software component of a database management system that handles the data storage, manipulation, and retrieval. It processes queries, manages transactions, and ensures data consistency and integrity, enabling efficient access to the database for users and applications. Please type database engine in the chat. When you take a database management system, the core component is referred to as a database engine. Database engine. Database engine. Let's take a database. Let's take a library as a database. The person in the database who handles the operations of organizing the books, arranging the books, giving out the books, knowing where all the books are, is the librarian. So in a database or in a database system, we have a core component that handles the manipulation of the database. And that component is called a database engine. In the context of AWS, especially RDS, Amazon refers to relational database management systems as database engines. All right, so this is because of how database engines or database management systems, or this is because of how RDS is built. The relational database system, it is built to operate on the relational database systems. And the core of this relational database system is a database engine. So outside the world of AWS, we may refer to MySQL as a relational database management system. And within it, we have a database engine. But in AWS, they refer to the database management system as a database engine. So when I ask you what database engine RDS works with, you will know the database engine to mention. You can mention MySQL because RDS is relational, so MySQL is good. All right. Let's talk about the challenges in managing a database. Managing databases involves setting up hardware, scaling resources with demand, taking regular backups, securing data from unauthorized access, and patching software. Tasks can be complex and time-consuming. So if you're in charge of managing a database, you are going to set up right from the basics, you set up the hardware for the database. You handle the resources, the installations, and everything it needs. You will handle the hardware resources as well, the memory, the block storage, and everything. You need to be taking backups. I remember how many backups I need to take all the time. All right. These tasks can be complex and time-consuming. Solutions like Amazon RDS automate many of these administrative challenges. So officially, we have gotten to the field of RDS. I'll use about 20 minutes to talk about RDS for us to understand what it is. Now that we have a clue of relational databases and database management systems, let's talk about RDS. RDS stands for Relational Database Service, and it is a fully managed relational database service provided by AWS that automates common database tasks. At this time, we'll watch a short clip about RDS, and then we will continue with the lesson after that. So let me share the video again, and we'll watch it.
Relational databases are at the heart of your most critical applications, but they can become difficult to manage and operate with high availability as you scale your app. Installs, patching, monitoring, performance tuning, backups, scaling, security, hardware upgrades, and storage management. Database administration is resource intensive, taking time away from building your application. Amazon Relational Database Service, RDS, simplifies database management by automating time-consuming administration tasks. With less operational overhead, your team can focus on optimizing applications and getting faster results. Amazon RDS gives you the freedom to use your relational database of choice, including the most popular open source and commercial engines, and Amazon's relational database built for the cloud, Amazon Aurora. Aurora is MySQL and PostgreSQL compatible and offers the performance and availability of traditional commercial databases at a fraction of the cost. RDS allows you to scale across a global footprint of data centers with enterprise high availability and disaster recovery no matter your size. RDS automates many previously cumbersome tasks: automatic failover, backups and point-in-time restore, disaster recovery, access management, encryption, secure networking, monitoring, and performance optimization. All these and more can be enabled with a few clicks or API calls. Even highly regulated industries can leverage RDS, which meets a broad range of compliance certifications. Hundreds of thousands of AWS customers use Amazon RDS today. Find out why with a free trial. aws.amazon.com/RDS.
Right. So with RDS, a lot of things are managed for you. You don't have to take care of all of that. A lot of things are done for you. This is why we say RDS is fully managed, and it's a wonderful service from AWS. All right. RDS, Amazon RDS, is ideal for applications requiring a relational database, such as web applications, analytics, and enterprise solutions. So any application that requires a relational database on AWS, you use RDS. We've seen how databases are important. So if you want a database in the cloud or in the AWS system, then RDS is what you should be thinking about. For relational databases, this is a relational, this is not a NoSQL database. It is a SQL or relational database system or service. It simplifies the setup, operations, and scaling of relational databases in the cloud, while automating time-consuming administrative tasks such as hardware provisioning, database setups, patching, and backups. So all of these are done for you. It is fully managed. Hardware provisioning, database setup, patching, and backups. What are the key benefits of RDS? RDS offers several key benefits for managing databases. Number one, automated backups. We talked about that. RDS automatically takes backup of your database, allowing you to easily restore at any point in time. As a matter of fact, they do daily backups. So instead of you backing up, and if you're in a busy environment, you see how databases change every day. They back up for you, and you can restore at any point if there's a problem. Scalability. It allows you to easily scale resources up or down with just a few clicks, adapting to changes in demand. High availability, multi-eases. RDS provides automatic failover to a standby instance in a different availability zone, ensuring high availability and minimizing downtime. So it provides automatic standby failure failover to a standby instance. So when there's a problem, a standby instance takes care of it in a different AZ, ensuring high availability and minimizing downtime. So when one has a problem, another one takes over. What do we mean? The underlying infrastructure of RDS is EBS and EC2. All right, that's why we are talking about instances running it. So these instances run your database. Security. RDS offers built-in encryption for data at rest and in transit, as well as integration with AWS IAM, Identity and Access Management, which we'll look at for fine-graining access control. So it provides a lot of security. Provides a lot of security as well. All right. So we'll talk about 4 benefits: automated backup, scalability, high availability, and security. Now let's talk about the relational database engine supported by RDS. RDS supports MySQL, which is open source, widely used for web applications. PostgreSQL, advanced features for complex queries. So these are the database engines, all right? So please take note. In AWS, when they ask you for the database engines, they are talking about the database management systems because the systems are built around the engines, or AWS builds RDS around the engines of MySQL, Postgres, and the rest. MariaDB is a copy of MySQL with additional features. So if you use GitHub or GitHub, you are going to see the term fork. This fork means you should create a copy of a repository. So we have MariaDB. Please have MariaDB. So these days you are going to be hearing a lot about MariaDB. We have MySQL, but you're also going to be hearing a lot about MariaDB. Type MariaDB. Thank you, Norbert. So MariaDB is a copy of MySQL with additional features. Then Oracle is enterprise grade with advanced capabilities. So Oracle is really, really secure. A lot of banking systems are built with Oracle. We also have MySQL Server compatible with Windows environments. We have Amazon Aurora, which is high performance cloud native database. So when we get to Aurora, we'll learn that AWS has built their own engine, and their engine is called Aurora, and it was built just for AWS Cloud. It's a cloud native database. Key features of RDS. First, managed database. RDS automates database administration tasks. High availability, built-in failover and read replicas. Scalability allows vertical and horizontal scaling. Security offers encryption at rest and in transit. A lot of encryption. Backup and restore, automated backups and point-in-time recovery. The last time we had point-in-time, we were talking about snapshots. So over here, you can see that snapshots also take place here. The last thing we'll talk about will be the pricing model of RDS. And Amazon RDS pricing is based on the instance type. Remember, it is running on EC2. However, you don't deal with EC2 directly because this is a fully managed service. It is also running on storage. So the type of storage, either the provisioned IOPS or based on the IO request that takes place on your system, the type of storage that you want. So when we learned about the volume types of EBS, talked about the high IOPS and the provisioned IOPS. So you have to understand that the storage is EBS. So we are paying for EBS, we are paying for EC2. Then backup storage on S3. Then the bandwidth or data transfer. So this is what pricing is based on. However, we have a free tier of 750 hours of T2 micro instance. So we talked about the instance types. We didn't mention their names much. Next time we'll mention the names. One is called T2 micro. Please type T2 micro in the chat. T2.micro, put that in the chat for me. So the instance types, some of them, they have names, okay? So later on, we may mention some of their names. So this is one, T2 micro. And you have free tier, 750 hours of T2 micro instance, which gives you MySQL and Postgres for 1 whole year, free tier. But after your free tier, you pay for the instance type you want to use, the storage you are consuming, backup on S3, and data transfer. All right. So officially, this is the end of the information on RDS. We have covered the fact that it is a relational database service on AWS. We've learned a lot about relational databases. And the last thing we'll do is to watch a demo on RDS, and then we'll say goodbye after that. So after the demo, I'll say a few words, and then we'll end the class today. If you're ready, let me see ready in the chat.
Hi friends, thanks for tuning in. In this video, we're going to cover the basics of Amazon's Relational Database Service, or RDS, and specifically how to use Microsoft SQL Server with it, though a lot of the same things will apply to the other database engines. We'll go build the database in just a second, but let me spend just a quick minute talking about theory here. In the land of databases, there are, of course, two big categories. We've got relational, where your data is stored in structured tables, and then non-relational, which have a more flexible structure. These are sometimes called NoSQL databases. We're going to focus on the left side here, relational databases, and in the world of AWS, that's going to be the Relational Database Service, or RDS. RDS is a managed database service, which basically means it's a database where Amazon does all of the underlying administrative work of setting up the actual server that it runs on, doing the backups, patching, recovery, and so on. So rather than you setting up a new server and going and installing something like Microsoft SQL Server directly and managing it, all of that stuff is done for you. Now, a quick distinction here. RDS is not the same as or another name for Microsoft SQL Server or PostgreSQL. Those are just two examples of database engines that are supported on RDS. The database engine, of course, is the underlying system that makes everything work. The query language, how you store and retrieve things from the database, and so forth. There's actually 6 different engines supported by RDS, shown here, and Microsoft SQL Server is just one of them. All right, but enough with the theory. Let's go create a database and see how to connect to it. Here on the console, I've just navigated to RDS. If you weren't here already, just type in RDS, and that'll bring you right here. So let's start by creating a database. There's 2 ways you can do this. You can use a standard create, which is where you get to go and select all of your options, or you can do an easy create, where Amazon's automatically configured things for you based on best practices. That's what we're going to do here, so we'll leave that one selected. Like we saw in the slides a second ago, these are the different engines available. For this video, we're going to be working with Microsoft SQL Server, so I'll select that. And then you need to select the instance size. So this is the actual server or virtual server that's going to be running everything. We want to go free, of course. The free tier will get a DB T2 micro instance type, and you'll see the additional details there. And then down below, some of this is filled out for us, but we can obviously change things. Your DB instance identifier, I'll just leave that at database-2. The master username, I'll go with admin as well. And I'll specify the password here. And confirm. And then you can view all of the things that are basically chosen for you by going with that easy create. Because this is just a basics video, I'm not going to get into too much detail. Just know that most of these things are editable after the database is created. We are actually going to go in and change one of these things afterwards. But this is going to take quite a while to create, so let's get that started. Create database. I do have one already up and running, database 1, so the new one we're creating here is database 2. You'll be able to refresh and see the status here. Right now we're creating. Now this is going to take a little while. When I was running this earlier for my practice session, it took about 20 minutes. So this is a good time to remind you, if you're finding this helpful so far, I'd really appreciate you hitting that like button so it can be shared with more people. And also think about subscribing for more content like this. Also, while that's running, let's talk about how we're going to connect to the database once it's up and going. If you've done any work with SQL Server in the past, you might be familiar with SQL Server Management Studio, or SSMS. I've got that open here and connected to another database. This is free to download. If you go to your favorite search engine, just type in SQL Server Management Studio download, and you'll be able to grab it from the Microsoft site. It's a free download right here. I'm currently using version 18.10. Another free tool you can use to work with RDS is called SQL Workbench at sql-workbench.eu. And as noted, first thing on the page here, this has no relation to MySQL Workbench, which is an Oracle tool. But this is another free download and another way to work with the Amazon RDS database. All right, like I said, we're going to be using SQL Server Management Studio, or SSMS. But before you can do anything, you need to make sure that your database is in an available state or status. It can't be creating or configuring backup or anything like that. So this is going to take a while. Like I said, I'll pause the video and come back when it's done. All right, our database instance has been created. Everything is good to go. We see the status is available. To connect to it from SQL Server Management Studio, we're going to need a few things. So let me click into Database 2. You'll see various details here about the instance. What we need to connect, though, is the endpoint and the port. And then on the Configuration tab, if you have forgotten it already, we have the master username here of admin. We're also going to need that. So let me grab the endpoint. I'll just copy this. I'll remember the port is 1433. And now let's head over to SQL Server Management Studio. And we'll say connect to a database engine. So we already have one connection going. This will be a new one. And then for server name, paste in that endpoint that you just copied out of the console. And then very importantly, you need to include the port at the end of this with a comma in between. So comma, and then port 1433. Don't put any spaces there. It'll just be the .com, comma, 1433. For authentication, you want to go with SQL Server Authentication like we have here, and then I'll enter that password that I used when I created this, and hit connect. Now we're going to let this do its thing for a second here. I'll tell you though, it's going to fail, but because there's lots of walkthroughs out there that have you do exactly this, I wanted to show you this error and then show you how to fix it. But you'll get an error something like this, cannot connect to this name that we entered. We'll say okay. Let's go back to the console. Now when we did that easy setup before, when we created the database instance, one of the settings in there was publicly accessible, and that is set to no. You'll see that here under security, which means that you can't access this outside of a virtual private cloud, or VPC, in AWS. And obviously we're not in the VPC, we're just on our desktop trying to connect from the SSMS client. So we need to make a couple changes here. If we scroll up, I'm going to click on Modify. You'll remember when we first started this, there was some settings that said they were modifiable after creating the database, and this is one of them. I'm going to scroll down here under Connectivity and then Additional Configuration. We'll want to make this publicly accessible. This is going to give your instance a public IP address. We'll leave everything else the same. Scroll down, continue, and then let's apply that modification immediately and modify DB instance. Now sometimes it says successfully modified up here on the top, but if you refresh your list, the status is actually modifying. So you'll need to make sure that finishes before you try to connect again. And I'll refresh, still going. And there we go, it's available now. So let's go back to SQL Server Management Studio and try that again. I'll hit connect. And I'll tell you, this is actually going to fail again. Apologies if this is a little tedious, but this is a really common error to come across. So let me show you how to fix this next issue. It'll be the same kind of a failure error that we saw before. But going back to the console, I'll click into Database 2. The next thing you want to check is the VPC security groups. So right here, you'll see VPC security groups default, that is active. And again, that was all set up just by doing the easy setup. We didn't choose that when we went to create this. Now, VPCs and networking in AWS, that's definitely a whole different video or set of videos. I don't want to dig too much into the details here, but in short, a security group is a set of rules for the firewall, basically saying what ports are available to accept inbound and outbound traffic. Down here, you'll see the inbound rules and outbound rules. Just give us a little bit more space here. And for the issue that we're having where we can't connect to our database instance, we need to add an inbound rule for MS SQL. So here with inbound rules selected, I'll say edit inbound rules. And we're going to add rule. The type here will be MS SQL. You'll see it automatically fills in that port 1433, the one that we were working with earlier. And then I'll just say this is from my IP. That'll be detected by the browser, and then save rules. So this will basically allow us to connect from SQL Server Management Studio on my laptop on my IP address. All right, let's try that connection one more time. That's the error from earlier. We'll try one more time to connect. Once again, we're going to leave everything the same up here. We've got the server name with the comma 1433 for port. Connect. And voila, now it works. Now before we dig in more here in SSMS, let me give you a little bit more information about connecting and VPCs and so forth. That last bit was probably a little bit hand-wavy, but if you need more information, I've put a link to this page down in the description for the video, so check this out. There's different scenarios for accessing your database instance, whether you're connecting from inside the same VPC or another VPC, or so on. So if you get stuck and you still have some issues on that connection, check out this link. All right, back to SSMS one more time. I'll collapse this first one that I was connected to. And this new one, database-2, let me just expand databases here. So this is connecting to the database up in the cloud. You'll see that we've got the SQL Server standard built-in system databases, master, model, MSDB, and tempdb. And you can expand these nodes here. This should look very familiar if you've done any database work or worked in SSMS before. You're also going to get a database called RDS admin. And Amazon RDS uses this to store objects that it uses to manage your database. But from here, you can create your own database just by saying new database, or you could run scripts to do that. Running a query, say new query. Do something like select at version, execute the query. You'll see the version of SQL Server that we're on, and so on. So again, if you've worked with a local SQL Server database before using SQL Server Management Studio, the experience here is going to be exactly the same, except you're connecting to the database that lives in AWS now. All right, before we wrap things up, very importantly, let's make sure we're saving some money. So back to the console. We'll navigate back to RDS. We ended up in the EC2 console for our security groups. And I'll click on Databases over here on the left. And you'll want to shut down the database that you created. Just select that, say Delete. For what we're doing, I'm not going to create a final snapshot, and I will acknowledge this is basically going to wipe everything out. That's okay. Delete me. And I actually had a second one here that I'll delete while I'm at it. You probably don't, but it'll be the same steps. And just make sure that everything gets deleted if you are following along so you don't have any surprise bills at the end of the month. But that's it. That's how to set up a SQL Server database using Amazon RDS and connect to it from the SQL Server Management Studio. Hope you found it helpful. Thanks so much for watching.
All right. Thank you very much. We've been able to see a demo on how to set up. The video goes beyond the basics. However, you saw how she was able to connect the database system, the RDS, to a local database software. Most of the time, we don't connect it outside AWS, but this video shows us that it's possible. And these are the database engines supported. If you want MySQL, you can use RDS, if you want MariaDB, Postgres, Oracle, and even Microsoft SQL Server, you can connect to all of them using RDS. So this is where we wrap up our lesson on RDS. Tomorrow, we'll continue with another service and we'll wrap up. Thank you all so much, and I'll see you in the next class. All the best. Bye-bye.